Alrighty, this is going to be the video to help you with part 2 of the Phet simulation. The big question we're trying to answer is, how does the force of friction affect the speed of the object? So to get us started, we want to click on, looks like the friction part of the gizmo. That's down here. Looks very similar to the first, I keep saying gizmo. It looks very similar to the first Phet, but the only thing that's different is that we now have the ability to control how much friction there is. We want to check all of the boxes in this upper right-hand corner. And then we are all set to do it's not a gizmo, the Phet simulation. There it is. Okay, it says use the table to describe what happens when you apply a continuous 500 Newton force to the following masses. The first mass is 40 kilograms, so that's the tiny little girl. And we want to apply, 500 Newtons of force. Things that we are going to be paying attention to. We want to figure out what is the amount of friction force prior to reaching top speed, and what is the sum force prior to reaching top speed. The last thing that we want to observe is when we do reach top speed and we stop applying the force, what kind of happens afterwards? So here we go, continuous force of 500. I'm just going to click, 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 click. Okay, looking at the friction force, there are 100 newtons. Oh no, I missed it. I missed what the sum force was. Go back. Let's do it again. Friction force was 125. Sum of the forces was 375. I keep missing it. I feel like this is difficult to keep track of. People in second hour were like, no, it's super easy. Yeah. Click those. All right, ready? 500 newtons. So 125 and then 375. So that's good. Okay, so what happens when we stop applying the force? Looks like we decelerate kind of slow. Takes a long time for us to eventually reach stopping, right? So put that in there. Took a long time to back to a stopped position. Okay, so let's do the next one, just so you know exactly what you're looking at. So we're going to apply 500 newtons of force to this box that's 50 kilograms. We want to look for what is the force of friction and what is the sum force. So we click that first. Force of friction is 125. Sum of forces is 375. Was that the right one? Did we just do this one? And I was supposed to do the girl first. Oh, you guys, I'm going to hit refresh. That very first row should have been the little girl, not the box. Ay caramba. No wonder it didn't make sense. Yeah, 100 newtons and then 400. Good grief. This should be 100. And this should be 400. And then the little girl took a really long time to go back to a stop position. And then you do the same thing for all the rest of them, okay? So again, when you hit 500 newtons, you're looking at what's the force of friction, what is the sum of the forces, and then just a description in general of what's happening to that object after the applied force has stopped. Ridiculous. Okay, so slide 14 says, what is the amount of applied force that is needed to overcome friction? Friction is the force that opposes motion, right? It goes in the direction opposite of motion. So how do we overcome that? How much applied force do we need? What evidence do you have based on the data from slide 13? In slide 15, it just asks you in general, what is the impact of friction on objects? And the big ideas that you should have gotten from this simulation. Objects with more mass experience larger forces of friction, making it more difficult for them to accelerate. Objects with less mass experience smaller forces of friction, making it less difficult for them to accelerate. All right, so this is part 2. Go back, rewatch anything that you need help with. Otherwise, go ahead and move on to part 3.